Let's take a look at square roots. This is Introduction to Square Roots. Just to show you what a square root looks like. Square root looks like this symbol. And then we have like a number underneath. Now what a square root does is you're trying to come up with something times itself. For example, 16 is 4 times 4. So we're looking for something times itself. Well, here's 4 times 4. If you find that, then the pair of 4s can come out in front as a single 4. And the radical disappears then. So that's what the square root does. You're looking for something times itself. Another example, if you had the square root of 9, well, that would be 3 times 3. And again, we're looking for something times itself. We're looking for a pair of somethings. Here's a pair of 3s. So a pair of 3 is going to come out in front as a single 3. Let me go back to 16. Now 16 I could rewrite as negative 4 times negative 4. Because negative 4 times negative 4 gives you a positive 16. And this would be a pair of somethings. Here we got a pair of negative 4s, which would imply that it's going to come out. And it could also equal to negative 4. But that's not true. Let me write a note up on that. A square root can only have positive numbers come out of it. So a square root can only have positive numbers come out of it. So square root of 16 equals 4 is just fine, but we cannot have square root of 16 equal to negative 4. So that's one of the things to keep in mind. And another one that we'll talk about later on in more detail, but just basically says if you have the square root of a negative number, so square root of negative number is not real. So another thing to keep in mind. And we'll talk more about these. Let's look at our first problem. We got square root of 25. Well, I do the prime factorization of 25. 25 is 5 times 5. And with a square root, we're looking for a pair of somethings. Here's a pair of 5s. So a pair of 5 is going to come out in front as a single 5. And then the square root disappears. Now here we got the square root of 1/4. Well, if I think of the top part, 1, well, that's 1 times 1. 4, that's 2 times 2. So 1/2 times 1/2 gives us 1/4. And again, we're looking for a pair of somethings. Here's a pair of 1/2s. So a pair of 1/2s is going to come out in front as a single 1/2. Decimals are kind of tricky. If I think of what gives me 2 decimal places, of course 5 times 5 gives me 25. But if I wrote this as 0.5 times 0.5, now we multiply those together, we get 25. And I got 1 decimal place here and I got 1 decimal place here. So my answer is going to have 2 decimal places, which is the 0.25. So we were able to write 0.25 as something times itself. And again, we're looking for a pair of somethings. Here's a pair of 0.5s. So those are going to come out as a single 0.5. And that's our answer. Number 4, we got negative 3 square root of 16. Now the negative 3 being out in front doesn't change anything. We look at the square root now. Well, we've already said 16 is 4 times 4. So we do the prime factorization if necessary, or you can do something different like 4 times 4. Now I say there's something different. Our prime factorization would be 2 times 2 times 2 times 2. But since we see this as 4 times 4, we can just do that. Well, here we have a pair of 4s, so those are going to come out in front as a single 4. And when they come out with multiplication with what's already out in front. So we got negative 3 out in front, so we got negative 3 times 4, which gives us negative 12. Now we had a note that said only square roots can only have positive numbers come out of it. But we have it equal to a negative number here. Realize that negative was already out in front. The only thing we brought out was a pair of 4s as a single 4. And it came out as a positive 4. Number 5. Square root of 121 over 16. Well, if I think of this fraction-wise, for 121, that's 11 times 11. And for 16, that's 4 times 4. So 11 fourths times 11 fourths will give you 121 over 16. Square root, so we're looking for a pair of something. Here's a pair of 11 fourths. So that's going to come out in front as a single 11 fourths. And that's our answer. Now in this one we have 5 plus 95. Well, a square root is kind of like parentheses. You do whatever's inside of there first before you try to tackle the square root. So 5 plus 95 is 100. Now I can do the prime factorization of this, but I also see that 100 is 10 times 10. And that's what we're looking for. We're looking for a pair of somethings. Here's a pair of 10s, so they're going to come out in front as a single 10. I think the next one's a calculator. Yeah. So I bring up my calculator. Okay, so we're wanting a square root of 21. Well, this is on T83, T84. Your calculator may be different, but I'm going to do a second x squared to get square root, and then I'll put in 21 and press enter. And we're going to round it to the indicated place. Didn't say. I guess I must have left that part out when I typed the problem up. I'll take it to 2 decimal places. So that'll be 4.58. Now this doesn't give us an exact answer. This would actually be an irrational number. So it's not an exact answer. Let me start a new page. And let's look at the next problem. And these next problems, they say tell if the square root is a rational, irrational, not a real number. If the square root is rational, find the exact value. If the square root is irrational, write the approximate value rounded to 2 decimal places. Okay, there's 3 things: rational, irrational, not a real number. Now, if you got a negative number underneath your square root, that's not a real number. So for number 8 here, that's not a real number. Number 9, we've got square root of 1600. Well, this one, 40 times 40, I think. Yeah, 40 times 40. Now, with square root, we're looking for a pair of numbers. Here's a pair of 40s. So a pair of 40s is going to come out in front as a single 40. Since I actually came up with the answer here, this one's rational. And for this one, we got square root of 31. Well, I can't do a prime factorization of this. This is prime. You know, I can't rewrite it as something times something else, because with a square root, you got to find a pair of somethings. Well, since I can't bring it out of the radical, this is a radical. It's a square root, but that's a special type of radical. Then it's irrational, and we'll put it in our calculator. So I'll do second x squared for the square root, put 31 in, and press enter. And I'll take it 2 decimal places, 5.57. would be our answer. And let's look at number 11. We got square root of y minus 8 to the second power. And they say y minus 8 is greater than or equal to 0. We'll come back to that. Now, square root means we're looking for a pair of somethings. Y minus 8 squared means I'm going to have y minus 8 times y minus 8. Well, here's a pair of y minus 8s. So a pair of y minus 8s is going to come out in front as a single y minus 8. Well, we said that for a square root, I had this on the previous page, we said a square root can only have a positive number come out of it. So we can't bring out a variable like this because it might be negative 2. If this was equal to negative 2, negative 8 is negative 10. But they specify that y minus 8 is greater than or equal to 0, which means it's positive, or it can be 0, which doesn't bother us. So that's our answer. Now this one right here we'll have to do something a little bit different with. I got 2x plus y squared. Well, 2x plus y squared means I'm going to have 2x plus y times 2x plus y. Now remember, with the square root, we're looking for a pair of somethings. Well, here's a pair of 2x plus y's, so that's going to come out in front as a single 2x plus y. Now, we want this to be positive, and we don't know what the values are. This could be a negative 1, this could be a negative 5, and this could equal negative 7. Well, a very easy way to make something positive is just to put absolute value bars around it. So that'd be our answer. So if you have something come out that's a variable, and you're not sure if it's positive, just put absolute value bars on it and it'll cover it. Now you don't need to do that with numbers. Like this 40 up here, we know that's positive, so we're fine. And that's the end of that lesson. So let me save this.